As we are learning engineering physics 1, so we know that in engineering physics 1, totally we are going to study 5 units. Our first unit is laser and optical fiber. So in laser and optical fiber, we are going to study the working principle. We are going to study the characteristics and properties of laser, then types of laser, then application of laser. So in the first part, in laser, we are going to study the principle, we are going to study the characteristics and properties, we are going to study the various types of the lasers, and finally we are going to study the applications of the lasers. For today's class, we are going to consider the principle of laser. As we know that the laser is defined as light is amplified by the stimulated emission of radiation. Light amplification, stimulation, emission, radiation is the expansion of laser, acronym for laser. So from this expansion, from this acronym, we can define the principle. The principle is the stimulated emission. Here in the principle of laser, we are going to consider rate of stimulated absorption, rate of spontaneous emission, and the rate of stimulated emission. So here the principle of laser is explained. The total theory explained with the 3 stages. First stage is the rate of stimulated absorption. Second stage is the rate of spontaneous emission. Third stage is the rate of stimulated emission. We are going to consider 3 stages to describe the principle of laser. So here, this principle of laser was explained by scientist Einstein. So here in laser, we called the principle of laser as Einstein's theory. According to the Einstein's theory, the rate of absorption is equal to the rate of emission. What input we are going to object, what input we are going to give, so that should be equal to the output. The rate of absorption, emission. So that parameters are called as Einstein's coefficients. So let's see the Einstein's theory. So for today's class, we are going to discuss about the Einstein's theory. We can call this Einstein's theory as Einstein's coefficient. Einstein's coefficients. We are going to give a constant values. That constant values is nothing but coefficients. We are going to measure the constant terms with the principles of laser and with fundamental physics background. See, under equilibrium, the rate of absorption is equal to the rate of emission. As we all know that here the emission are 2 types. One is a spontaneous emission and another one is the stimulated emission. Spontaneous emission, emission of the radiation without any additional triggering. Stimulated emission, the emission of the radiation with some inducement. So according to the author, here the rate of absorption is equal to rate of spontaneous emission plus rate of stimulated emission. So we are going to measure the parameter for a rate of absorption. Then we are going to measure the value for rate of spontaneous emission, and we are going to measure the value for rate of stimulated emission. Then after measuring the datas, we are going to place the datas in this formula, in this condition. Rate of absorption equal to rate of spontaneous emission plus rate of stimulated emission. So we have to measure the values and we have to place the values here. Then we have to find the Einstein's coefficients A and B. So here we are going to consider the coefficients as A and B. Let's start. So what we are going to do. So here from this slide, we can able to understand that the principle of laser based on the three processes: stimulated absorption, spontaneous emission, stimulated emission. So here I have shown the systematic diagram. So this first diagram is for the rate of spontaneous absorption. Initially the atom is in the lower state. We are applying the energy. The energy is gained by this atom. After acquiring the maximum amount of energy, the atom in the ground state goes to the higher state. The process is called rate of stimulated absorption. Stimulated means we supplying the energy. So the energy makes the particle to disturb. The energy makes the particle to move from its position. Initially the particle is in the ground state. After gaining the energy, the particle will elevate, go or moves to the higher state. The process is called rate of absorption. The second process are rate of spontaneous emission and rate of stimulated emission. As we know that the rate of spontaneous emission takes place from the higher state. Now the atom is in the higher state. When the higher state atom jump to the ground state without any additional energy, without any inducement, then such type of process are called as spontaneous emission. The atom in the higher state jump to the ground state without any additional inducement. Such type of a process are called as rate of spontaneous emission. The third process is rate of stimulated emission. The atom in the higher state jump to the ground state with some energy. Atom in the higher state jump to the ground state with inducement. Action plays on the basis of stimulated emission. That's why we are saying that the principle of laser is the stimulated emission. So this stimulated emission is the last stage of the mechanism. So this entire mechanism was explained by the scientist Einstein. So it named as Einstein theory. In Einstein's theory, we are measuring the Einstein's coefficient, the value of A and B. So let's see one by one. Let's see the process one by one and the values. See, I already informed that according to Einstein's theory, rate of absorption equal to the rate of emission. You should not forget this term. Rate of absorption equal to the rate of emission. For our case, we are having two different types of emissions. Spontaneous emission, stimulated emission. So the above condition modified as rate of absorption equal to rate of stimulated emission plus rate of spontaneous emission. So these our consideration. We have to consider these term. Now we are going to measure the values for this term. Let's start the first stage. Here we can able to see the rate of absorption. So the rate of absorption is given by the symbol R12. R stands for the rate. R stands for the rate. Here 1 and 2 stands for the change, displacement, the motion of the particle. So initially the atom is in the ground state, that is 1. Initially the atom is in the ground state, that's why we are writing as a 1. The ground state atom, after gaining the energy, it will go to the higher state. It will go to the higher state. So we are writing the number 2. 1 to 2. Ground state to the higher state. So that's why we are writing a symbol as R12. So let's start the process. So here we can able to see the energy level diagram. Energy level absorption. Here from this energy level diagram, this line is nothing but the ground state. This line is the higher state. So we have to imagine that. It's an assumption concept. We have to imagine that there are n number of atoms, not only a single atom, but there are n number of atoms in the ground state. That's why we are using the number here n1. N1 stands for number of atoms in the ground state. We can able to see the term here. N1 equal to number of atoms in the ground state. So for our convenience, to explain the concept in the simple way, we have considering a single atom. But in reality, it containing n number of atom. It having n number of atom. That's why we are writing the number n1. Okay. So we are having the ground state. We are having the higher state. Initially, all the atoms are available in the ground state. So for these ground state atoms, we are going to supply the energy. That energy is nothing but applied field. We can apply two types of energies. One is electron beams and the second one is the photons. We can apply electron beam as an input energy. Second, we can apply the photons as an input energy. What is this electron beam? What is this photon? If your input field is an electric current, then it's electrons. If your input field is the light source, then it is photons. The photon means light. So to explain the Einstein's theory, we are going to consider the applied energy as photons. The photons is nothing but a light energy. So we are applying the light energy as the input, and we are going to get the light energy as the output here in the Einstein's theory. So let's start our mechanism. Ground state E1, higher state E2, the number of atoms available in the ground state N1, the number of atoms available in the higher state N2. For this ground state atom, I am applying the energy. The energy is the photon. E is equal to h nu. The energy of the photon is E is equal to h nu. When the energy is applied to this ground stated atom, the atom gains the energy after accumulating the maximum amount of energy. The atom will goes to the excited state. The atom from the ground energy state goes to the higher energy state with occurring external applied energy. So this process is called as rate of absorption. Now we have to assign a condition for this. How we are going to assign a condition? See, the rate of absorption R12. Already I have informed that the rate of absorption is given by the symbol R12. The rate of absorption is directly proportional to applied field. So when the field is applied, then only the atom will move. When the field is not applied, then all the atoms will be rest in the ground state. There will be no any change. So the rate of absorption is depends on the applied field. Here for the applied field, we are using the symbol rho v. Rho v. Second, on number of, so the second dependent is N1, the number of atoms now in the ground state. The ground stated atom is given by N1. Therefore, the rate of absorption is given by R12 proportional to rho v into N1. Rho v is the applied field, N1 is the ground state. We have to see the location of the atom. From there only we can write the condition. So now the atom in the ground state. That's why I am mentioning the symbol N1. Second, I have to remove this proportionality and I have to introduce a proportionality constant. So I am using the constant here as B. So B is a Einstein constant. So here the atom is moving from the ground state to the higher state. Therefore, we are writing the symbol as B12. R12 is equal to B12 rho v N1. So these be the first condition. We have measured this one, rate of absorption. Listen carefully. The rate of absorption R12 depends on applied energy, that is rho v, and it depends on number of atoms. So they are the directly dependent. They are only going to change their position. So R12 proportional to rho v into N1. Removing the proportionality and introducing a constant becomes R12 equal to B12 rho v N1. So be careful with this condition. If you are dealing with the ground state, you have to mention the symbol as 12. You have to write the parameter as 12. If suppose you are dealing with the higher state, there you have to mention the numbers as a 21. That we are going to see in the next part. The first one is the rate of absorption. The second one is a rate of spontaneous emission. We have this. So based 3 able to A and B. We completed the first one, rate of absorption, ground state to the highest state. R12 proportional to rho V N1. R12 equal to B12 rho V N1. Now the second one, imagine that now the atom is in the higher state, not in the ground state. It goes to the higher state. When the higher state atom jump to the ground state without any additional energy. Here we have not shown any additional energy. If it jumps directly, then this process are called rate of spontaneous emission. So to mention the rate of spontaneous emission, we consider the symbol as R21. Actually here this symbol is R21. By mistake I have given as R12. Sorry. R21 spontaneous. The atom from the higher energy state jump to the ground energy without additional energy, without any inducement. So if there is no additional energy, then we have to consider as rho V is equal to 0. We have to consider rho V is equal to 0. Then we can write the rate of spontaneous emission R21. Here it's clearly mentioned R21 spontaneous directly proportional to N2, because here we are not having an energy. Rho V is 0. So we are considering only the number presence. That's why R21 spontaneous directly proportional to N2. Then we can write R21 spontaneous equal to, sorry, it's 21. I have mentioned as 12. Sorry. R21 spontaneous is equal to, here I have taken the constant A. A21 N2. So this be the second condition. This be the second condition. R21 spontaneous equal to A21 into, here we mentioned as R12 is equal to B12 rho V N1. Rho V because we applied the energy. Here we are not having the additional energy. That's why the term rho V is eliminated, considered as 0. Eliminated. We are eliminating the term. The final condition R21 spontaneous is equal to A21 N2. So this will be the second case. The third case, rate of stimulated emission. So for a rate of stimulated emission, the symbol R21 stimulated. R21 stimulated. See here we can see that the atom is in the higher state. The higher state atom jumps to the ground state. So there are some noise. Please mute your microphone. Someone has unmuted their phone. The atom in the higher state now jump to the ground state with the additional inducement. So when there is an additional inducement, then we have to mention the symbol rho V. We can make the condition as R21 stimulated directly proportional to rho V, because here we are having an additional inducement. So we are using the term rho V. Now the atom is in the higher state, N2 level. So we are using the term N2. Therefore, R21 stimulated equal to, here the constant is B21. Actually, we are using this term B for both case. One for the rate of absorption. Here also we are using the term B, but here B is in terms of 1 and 2. So here also we are using the term B, for a stimulated emission, but is in the form of 2 and 1. So for the energy dependent term, we are using the symbol B. For the non-energy dependent term, we are using the symbol A. So we have to be more clear in this process, where we have to put B1, where we have to assign B2, and where we have to assign A21. So we have to be more clear with the constant, because the students will make a blunder mistake here. They will never know what to write as a constant. If you are writing for the absorption, assign the symbol B. Absorption takes place from ground state to the higher state. If you are talking about the stimulated emission, so this emission is the laser action. Atom from the higher state to the ground state with inducement. Same symbol. So the first, from the rate of absorption, R12 equal to B12 rho V N1. The second parameter, the rate of spontaneous emission, R21 equal to A21 N2. The third parameter, rate of stimulated emission, R21 equal to B21 rho V N2. So totally we are having 3 rate of absorptions that we can see here. The rate of absorption, the first stage, R12 is equal to B12 rho V N1. The rate of spontaneous emission, actually 21, this one is a 21, R21 is equal to A21 N2. Similarly, the rate of stimulated emission is R21 is equal to B21 rho V N2. So students, please consider these 3 equations. So these 3 equations is a very important equations here in laser, because this Einstein coefficient is a repeated university question. It a small derivative part, but the derivation is very simple. The basic mathematical steps only we are going to consider, along with some fundamental principle of physics. So here the rate of absorption R12 is B12 rho V N1. Rate of spontaneous emission R21 is equal to A21 N2. The rate of stimulated emission is R21 is equal to B21 rho V N2. So kindly make a note of it. These 3 equations is very important. Just you see these 3 equations, where we are using the symbol rho V, where the symbol rho V is not used, why it's not used, everything you should know. So this rho V is an input energy. This rho V is an additional induced energy. Here there is no inducement, directly jump. That's why no rho V. So now we can start our derivation. You can see here I have placed the equations. Rate of absorption B12 rho V N1, this value, equal to rate of emission. So here, according to Einstein's assumption, emission are 2 types: spontaneous emission and stimulated emission. So for spontaneous emission, the value is A21 N2. A21 N2. For stimulated emission, the value is B21 rho V N2. B21 rho V N2. So first we have to place the assigned values in the above condition. We have to place these obtained value in this above condition. After that, so what we have did, we have made the constant parameters in the left hand side. V12 rho V N1 minus, so this term is coming towards the left hand side, minus B21 rho V N2. We can able to see the change. So the B21 rho V N2 come to the left hand side. Then it becomes minus B21 rho V N2 equal to A21 N2. A21 N2, the same readings. Now take the common parameter out. So we can able to see the common parameter out. The common parameter is rho V. Let's take this common parameter out. Then we can write B12 N1 minus B21 N2. B12 N1 minus B21 N2. The rho V becomes a common, equal to A21 N2. No change. So from this condition, we are going to measure the density, that is rho V. So the density rho V is equal to A21 N2 divided by B12 N1 minus B21 N2. So these are all the basic mathematical steps. You have to know the values. If you know the values, please place these values in the Einstein's condition. Then you can find the value of rho V. So here, after this, what we are going to do? So these condition on further, the changes I have given here. So what we are getting this final result, I have given the steps for it. What are the steps we have to follow? See, rho V is equal to, what is here? The same thing also here. A21 N2. B12 N1 minus B21 N2. Then rho V is equal to, please make this N2 to be here. So we are making some modification. Rho V is equal to A21 divided by B12 N1 minus B21 N2 divided by N2. This N2 coming here. Then simplify this term. Rho V is equal to A21 divided by B12 N1 by N2 minus B21 N2 by N2. So I have just simplified this N2 on both the sides. I placed this N2 on both the sides for simplification. We get B12 N1 by N2 minus B21 N2 by N2. So the N2 and the N2 are the common term. We can cancel out. Finally, we get rho V is equal to A21. Rho V is equal to A21 divided by B12 N1 N2 minus B21 N1 N2 minus B21. So I will stop up to this right now. If you have any doubt up to this, you can ask your doubt. If not, we can proceed. Any doubt? Akash?
Yes, sir.
You have any doubt?
No, sir.
Is it clear?
Yes, sir.
Very good. Dhoni player.
Sir, the last one was the derivation for cumulated absorption, no?
Yeah, I can't catch you. What your question?
Last one, the derivation.
Stimulated absorption, actually we measured 3 parameters here. See, our objective is to measure this laser action. Our objective
Yes,
is to measure this laser action. So
Yes,
for
sir.
to measure this laser action, according to the Einstein's hypothesis, we have to follow the stages. First stage, second stage, third stage. So here, from these 3 stages, we are going to measure how much we are going to get the outcome.
Okay,
That only
sir.
we have shown here. So this is the energy. So now we are going to measure the coefficient. Here I have mentioned A and B. I have mentioned the value of A and B. So for this value A and B, I am going to get the condition. I am going to get the condition. So that's why I have stopped up to this, because on the next slide we are going to consider some basic principle.
Okay, sir.
Then we have to compare that principle with our laser, and we have to solve the equation further. Is it clear?
Yes, sir.
Okay. So we have just completed this equation. Rho v is equal to A21 by B12 N1 by N2 minus B21. Now we have to measure the value of N1 and N2. We have to know what is N1 and we have to know what is N2. So to find the value of N1 and N2, to find this value, we are going to consider a constant. That constant is Boltzmann's constant. According to the Boltzmann's distribution law, the number of energy in the energy state is given by N is equal to N naught e power minus E by kBT. So this is the general condition. N is equal to N naught e power minus E divided by kBT. But here, for our case, the N classified into 2. One is N1 and another one is N2. So we have to make the N value as N1 and N2. See, N1 is equal to N naught e to the power minus E1 by kBT. I have taken as condition number 2. Similarly for N2 is equal to N naught e power minus E2 by kBT. I have taken as condition number 3. Now, to find this value of N1 and N2, so we have to substitute the value of N1 here and we have to substitute the value of N2 here. By substituting and by solving, we get what is N1 and N2. So that be the final step. See here, N1 is equal to N naught e power minus E1 by kBT. N2 is equal to N naught e power minus E2 by kBT. From 2 and 3. From 2 and 3, N1 by N2 is equal to, substitute these values here, N naught e power minus E1 by kBT divided by N naught e power minus E2 by kBT. Cancel the common term. N naught is common, so we are cancelling the term N naught. Then we get N1 by N2 is equal to e power minus E1 by kBT divided by e power minus E2 by kBT. So next what I am going to do, I am bringing this e power minus E2 by kBT to top, to the upper side. So when we bring this exponential term to the upper side, the sign will change. The sign will change. We can see here. So n1 by n2 is equal to e power minus e1 by kbt, the same one. So this term is coming up. So it became e power minus became plus e power plus e2 by kbt. So here exponential is common, e is common, so we can combine these two and we can make it as a simple. Therefore n1 by n2 is equal to e power positive term first, e2, then minus term. This e2 minus e1 is equal to h nu, because so at the starting itself I have mentioned that E is equal to h nu, but here E is nothing but we are having as a E1 and we are having as E2. The difference between these two is nothing but E. So the E can be written as E2 minus E1. The reason, the laser action takes place from the higher state to the ground state. That's why we are mentioning as E2 minus E1 is equal to h nu. This E2 minus E1 becomes h nu. So we can write N1 by N2 is equal to e power h nu by kbt. Instead of this E2 minus E1, we can write as h nu. So this condition is the next step. Is it clear? Have any doubt?
Yes, sir. No, sir.
Okay. So we are having only one more step for to complete this Einstein's coefficient, Einstein's theory. So this question is a very, very important question. If you know the basic three parameter, rate of absorption, rate of spontaneous emission, and rate of stimulated emission, you can go ahead and you can complete the process. But in two stages, we are using the constant data. So these are constant data. And also in another one stage, we are going to use this constant data, that is here. See, now we know that the value of n1 and n2 is equal to e power h nu by kbt. Now substitute the values here in n1 and n2. So in this condition, rho v is equal to a21 by b12 n1 n2 minus b21. So instead of these n1 and n2, we are going to substitute value as e power h nu by kbt. Now we can able to just see the changes. So I will stop up to this. So the remaining we will see in the next class, because we have to expand the term and then we have to compare the term with the another constant and we have to write the final result. So this is the Einstein coefficient. What you are seeing here, this will be the Einstein coefficient. This result. Taken the Boltzmann distribution. Now we are going to consider Planck's energy distribution. So then only we can able to get the final result. So I will stop up to the condition number 4. So if you have any doubt up to this condition number 4, you can raise your doubt. Otherwise, I will show you the questions. I will give you the questions. You can answer your questions. You can answer the questions and you can have your answers. In the next class, I will randomly call one by one and I will ask the solution for the question. Is it clear? Can you able to catch me what I am saying?
Yes, sir.
Yes, okay. So I have stopped up to this condition number 4. I never completed the Einstein theory. I have stopped up to condition number 4. So there are some more condition for to get the result. But now I have placed some questions here. Please copy this question. We are having 5 minutes time. So please copy this question. Write your own answers. You have to write the answers on your own. And you have to keep the answers with you. I will call one by one and I will ask the question and you have to say the answer for this question. So please copy this question. I will place this question in our chat box also and also in our WhatsApp group. The students, those who are joined in the WhatsApp group, they can able to see this question in future. Are you all writing?
Yes, sir.
Okay, copy the questions. Once you completed, let me know, then we can end our class.
Sir, finished, sir.
Yeah. Majority. I need a majority reply.
Yes, sir.
See,
Finished.
okay, those who are finished, those who are just copied this question, they can just one second. Those who are completed, they can leave the.
I am completed.
Yeah, okay. Those who are completed, say anything, you can.
Thank you, sir.
I asked the representative of the department to place their phone number in the chat box so that the other persons of your department can get your contact to share their number.